let's talk really quickly. Shh. Guys, quiet, please. Right, about direct variation. Direct variation is modeled by the following equation. And where K is called the constant of variation. Okay, so what does this look similar to? What equation that we've been working with? This looks pretty similar to mx plus b, right? Yeah. Okay, good. So basically the constant of variation is another way of basically saying a rate of change, right? Okay. And then what you see here is for a direct variation type of problem, what is the y-intercept? Yeah, it's 0. So the y-intercept is just a 0, and the slope is whatever your constant of variation is. Now, here's why it's referred to as direct variation. If you took the equation y equals kx and you solve for k, that actual constant of variation, you can solve for it by dividing both sides by x. So k is equal to y over x. So what that means is, since the ratio y over x is always going to be the same in a direct variation, that means if you multiply y by 2, what do you have to multiply x by? 2. If you multiply y by -5, what do you have to multiply the x by? So it's directly related, right? Whatever you manipulate, whatever factor you scale y by, you have to scale x at the same factor. So that's why it's called direct variation. They're directly related as far as the scaling goes. Okay, now here's the type of problems that you're going to see involving this, and really the solutions are no different than what we've done with slope-intercept form, except it's even simpler because the y-intercept is always 0. Okay, so you'll get something that says the following. X and y vary directly. Okay, you'll get some form of this statement. It might say x varies directly, or y varies directly with x, and so on. Okay, and then it'll give you a set of information. So it might say when x is 6, y is 3, and then it might ask you to find the direct variation equation. Okay, so this is the way that you're going to see a problem, and I'll show you a couple other ways that information is going to be presented. Okay, but this is pretty much, it's going to have the very directly. It'll give you a set of values, so you can see when x is something, y is something else. There is the set of points that you're going to use to solve for. And so you're either going to ask to find the constant of variation, you're going to be asked to find the direct variation equation, or you're going to be asked to evaluate when x is some specific number. Okay, all of them start with this same process, and the process is simply to plug in the x and y value that you're given into this direct variation equation, y equals kx. Okay, so our first step here for this problem is our y value is 3, so we plug a 3 in for y. Our k is our unknown, our x value is 6. And so if we plug that in, we're then going to solve for k. In this case, we divide both sides by 3 or by 6. We're left with k is equal to 1 over 2. Okay, and then depending on what you're asked, so if all you're asked to do is find k, you're done. If not, you'll be asked to substitute k back into the y equals kx equation. Okay, so in this one, to find the direct variation equation, we have y is equal to, our k value was 1/2 x. And so that's all you'd have to do.